Hello and welcome to the introduction to Clean Code Nuggets. In this presentation, we'll firstly cover a brief introduction to myself and then a brief definition on what Clean Code is, why it's important to us, and then what Clean Code Nuggets will involve. My name is Steve Bamford. I've been working in RES as a software developer for over 10 years now, in professional software development for over 20 years, but I've been programming for over 30. Now, in those 20 years, software development has become a much more mature industry. We now have better practices that hopefully lead to better software being written, and one of these is the concept of clean code. Anytime that you write software, it has the primary purpose of telling the computer what to do. However, unless you're going to throw this code away after you write it, there's an important secondary role, and that is to communicate what the code is doing to someone else who is reading that code. This is where the concept of clean code comes in. Now, there are a lot of different definitions of what clean code is. The clearest I've come across is this one, which is that it's easy to understand and easy to change. This may sound easy, but it takes a lot of practice and discipline to do this effectively. So let's break that down a bit and look at what easy to understand means. One of the main advocates of clean code is Uncle Bob, and he uses this image to explain what good and bad code is. It's based on the idea of questions per minute. When you're reviewing some code, the lower the number of questions per minute, the easier the code is to understand, and the cleaner it is. And let's have a look at some simplified Python code to demonstrate it. This is REST code for a single class that we've recently been using. We've removed the code within the functions to keep it simpler. Is this good code? Let's measure the questions per minute. Even in this very simplified code, there are a few questions. Firstly, the class name. A factory is a standard design pattern for creating objects. So this name suggests that the class creates coordinate systems. But do the functions do this? The second question is res CSID. Now, what is this? It's probably a res coordinate system ID, which we'll use to create a special reference. But is it the same thing as coordinate system ID? If so, why are they different? Is the difference deliberate? And the third main question is res to EPSG. It's not clear from the name what this function is actually doing. Is it converting a res coordinate system to an EPSG coordinate system? Without looking at the code, well, we just don't know. Now, you could well argue that if we look at the underlying code, we can work out what this code is actually doing. But that is actually the job of the names of the functions and parameters. Anyway, we'll come back to this example later. The second part of the definition is easy to change. Now, modern IDEs really make code easy to change through the refactoring tools that they provide. These tools quickly and reliably carry out standard tasks like renaming a function, as shown here in Visual Studio for C# code, or here in PyCharm for Python code. You click once on that tool, write the new name, and your code is reliably updated. However, the phrase easy to change is a bit simplistic. It should really be easy to change and produce the expected result. You can easily make a seemingly simple change to your code, and the end result changes unexpectedly. How do we know if a change has had unforeseen consequences? That is where tests come in. If you run a test that executes some part of your code and it produces the expected result, your test passes, and you can be confident that at least that part of your code is doing what you expected it to. Now, why is clean code important? It's important that your code is easy to understand because of the secondary purpose of the code. Something's going to change, and people are going to want new features, or they find bugs in the current software, and whoever's going to add the feature or fix the bug is going to have to understand the code first. Now, programmers spend a lot more time reading code than writing it. The actual ratio is debatable, but it's often quoted as being 10 to 1. You spend 10 times more time reading code than actually writing it. If you write code that's difficult to read, then it takes longer and so it's more costly to make changes to that code. As shown on this graph, bad code makes the cost of change go up over time, as shown by the black curve here. Hopefully with clean code we can get closer to the green line, the optimal cost of change. Note that the black line starts lower than the green one. This is an important point. Bad code is quicker to produce initially, but soon it becomes more difficult to change, and this burden gets worse over the life of the software. Is this initial investment in writing clean code worth it? Well, in general terms, you'll spend more time maintaining software and more cost maintaining software than developing it. Ballpark figure is that maintenance costs around 60% of the total over the lifetime of any software. If you can reduce the cost of maintaining your code with a little bit more cost up front, then it's almost always a good investment. So clean code should help us to reduce the long-term cost of software. Now, what are Clean Code Nuggets? Well, Clean Code Nuggets will be a series of short Skype meetings during which we'll be covering the principles and practices that help us to write clean code. We'll be using real res code in these demonstrations, so if you have any code that you want to be included, please let me know. For those who cannot make the Skype meetings, we'll be recording them and making them available on a stream channel. And discussions and questions either during the meetings or afterwards are of course welcome. Hopefully, Clean Code Nuggets will help people across Res to write cleaner and better code and produce better software. As a quick example of the kind of thing that we'll be doing, let's go back to our example from earlier and see if we can find and fix the 3 questions that we spotted earlier. Firstly, by looking at the usage of this code, the second function, res2psg, is only used within this class, so it's actually a private function. This leaves us with only one publicly available function, which creates spatial references. So the class name is actually quite clear given this functionality, and we can rename it accordingly to a spatial reference factory. Looking at the public function, we can identify what the input parameter is there for and rename it and the function so its purpose is a bit clearer. Create spatial reference, providing a res coordinate system ID. From looking at the usage of the second private function, we can give it a better name and provide a better name for the input parameter as we know where it comes from, and after reviewing the details of the code, we can give the function a much more explicit and accurate name. Get EPSG code for res coordinate system, given the res coordinate system ID. So now, when we look at this class, the name, spatial reference factory, tells us what it's there to do. It's there to create spatial references. And it's more obvious what the public and private functions do and what their input parameters are that they're expecting. So that's it for this introduction. I hope it's been useful, and I hope that you'll join us for our first Clean Code Nugget, which will cover the seemingly simple subject of naming. Thank you, thanks again, and happy coding.